Hey guys, let's discuss new problem from graph which is called count the number of distinct islands. Okay, so for example, you have given graph something like this, 0 0 0 0 0 0 0 0 0 1 1 1, and let's say this one. Okay, this is the adjacency matrix you would be given, and let's say this is the vertices 0 1 2 3 4 0 1 2 3. Okay, so now you need to find how many islands are there. Okay, so for example, this is one island, means which has the 1. Okay, 1 is land and 0 is water. This one is second island, right? And this one is third island. But the twist here is that you need to find unique islands. So for example, this one and this one is the shape is same for these islands, right? So they are not unique. The answer should be one of this is first and this is second. Okay, so you need to remove duplicate, not remove, the answer should not contain them. So this is very simple. Okay, we will take one hash set and we will store coordinates of these graph. Okay, shape of the islands, and then hash set will remove the duplicate. Okay, now the question is how you will store it. Very simple. See, let's say what is the coordinate of this one? It is 0 0. Okay, the coordinate for this one is 0 1, and this one is 1 0. So what we will do, this first one will we will call it as base coordinate, and we will subtract this base coordinate from every coordinate. So for example, 0 0 0 minus 0 0, so it will be 0 0 only. Okay, then 0 1 minus 0 0, so you will subtract x with x and then y with y. Okay, so this one will be 0 1 and this one will be 1 0, so same only, right? Now let's check for the this graph. Okay, what is the coordinate for this graph? This is 3 0 3 1 and 4 0. So my base coordinate will be 3 0, so I will subtract this 3 0 from all the coordinates. So from here, if I subtract, so this one will become 0 0, this one will become 0 1, and this one will become 1 0. Okay, now can you check this one and this one is same? So that is how you will find that whether the shape is equal or not. And when you store this in a hash set, okay, store it in as an array list and store that array list into a hash set. So this 2 will come once only, and then you can store this one also. Okay, so you will have two shape here. So that is the logic, and that is very simple. Okay, you just visit each node which has the number 1 and apply DFS if it is not visited. That's it. Okay, so what we are doing here, you have given a one grid. Okay, and then you will calculate its n and m. Okay, number of row, number of column, and then you will create one visited boolean array. Okay, that is what we do for all the graph related problem, right? One queue you have created for BFS. Right now not queue, the visited array, just to check whether that node is visited or not, so that you won't be process it means next time. Okay, and then after that you will iterate the grid. Okay, and you will check if it is equal to 1 and it is not visited, then you will create one array list. Okay, to store this shape, like this one you will store this in one array list. Okay, so that's why you have created array list of a string which is called shape, and you will apply DFS and you pass this shape here. Okay, and then after that you will add this shape into the array list. So and also one more thing, when you are looking for this vertex, right? So after that you will look at when you are applying DFS for this one, after that you will check its neighbor node also. And neighbor node, what, how? Top, bottom, left and right, the same way what we were doing from earlier one also. Okay, so and then return at the end set dot size. Now what is happening in this DFS function? So this is the function. Okay, see here, if you see how we are passing the parameter ij, ij. Okay, so first ij will be your row and column, and second ij will be your base coordinate. So that will be same for all, right? And then grid, visited array and shape. Okay, after that you will find what is the number of row, number of column, and then you will mark that visited r c to true, and you will add that first means this one, you will add this first coordinate, okay, into the shape. Now to traverse it for top, bottom, left, right, this is the way how you traverse the neighbor node. Okay, then so you will run it four times, because you need to traverse top, bottom, left, right, and then you find new nr and nc. Okay, new row, new column, and you have to check 5 conditions here. Okay, 5 or 6 conditions. So first one is your new row, new column should not be less than 0. Okay, so this one they should not come here, right? It is invalid this after this before this columns. So that one will check using this 2 condition. Okay, and then it should not greater than n and m, so that will check these conditions also, right? So it will check your underflow and overflow condition, and after that if grid of nr nc is equal to 1 and it is not visited, then only you will run DFS again for its neighbor node. Okay, and then recursively you will run this. So that's it. Thank you.